Hi, I'm Tim Berglund with StarTree. Welcome to Pinot 101, Streaming Ingestion. There are two ways to ingest data into Pinot: batch and streaming, or as they're sometimes called, offline and real-time. This is the second. This is how to do it from a streaming source. So conceptually, what does this look like? If you've watched the module on batch ingestion, you know the idea there is that you're reading from some set of data that's stored somewhere, creating segments, pushing them into the cluster. Well, the notion here is that you got some kind of streaming input. Could be Kafka, could be Amazon Kinesis. It's usually Kafka. I'm just going to show that here on the slides. And that table is, in effect, logically connected to a topic in Kafka. And Pinot itself is being a Kafka consumer and consuming records from that topic. All right, so you've got Kafka, we're consuming from it. Where do those messages go? Well, we are only getting maybe one of them at a time or some small batch of them at a time, not enough to create a whole segment the way we would when we're doing offline or batch ingestion. What happens, logically inside that table, there is this thing called a consuming segment. Now, physically, it actually resides on the server associated with that table. That consuming segment is an in-memory data structure. And Pinot here, the Pinot server in this case, is acting natively as a Kafka consumer. There's no Kafka Connect or anything like that. It's just directly connecting to Kafka, consuming those messages. For each message, as is consumed, it's written to the consuming segment. And as soon as it's written to the consuming segment, it's available for querying. So there's no latency. As soon as I've ingested a message from Kafka, that can show up in a query result. If the server has issued a query right after that ingest, right after that consume is complete, it's there for the querying. And if you remember from the beginning of this course, we talked about the three characteristics of a real-time analytics database. Freshness was one of them. So Pinot is imposing basically no additional delay here on how long it takes for data to be queryable. All right, so we're consuming from this Kafka topic, and what happens? Well, that consuming segment fills up. Okay, it's in memory, and we put as many things in it as we can, and we have to flush it. So that's going to flush to a regular old segment file on disk, like we would see in an offline table. We're going to keep consuming. That's going to fill up again. We'll flush to another segment. So this will be after we hit a certain memory threshold or a certain number of records or time or various configurable ways of deciding to flush, but we keep flushing to those segments in the table. And that's the conceptual basis of how real-time ingestion works. Now, let's get our eyes wrapped around a few files and take a look at what this looks like in terms of some details. So I got this JSON data. This is more likely that the data in the Kafka topic would either be Avro or protobuf or JSON. And JSON's a lot nicer to look at. So, here's this JSON data that I'm ingesting. It looks like that. You can kind of get an idea of the schema. And of course, we would build a schema file. I'm eliding that step. If you've watched the module on batch ingestion, you've seen what a schema file looks like, kind of get that idea. But here we have our table configuration file. Now, that table config file, notice that second line, table type is real time. So that's what we call a table that is ingesting from a streaming source. It's a real-time table. Various other things there. I want to draw your attention in the middle here to the stream configs. It says the stream type is Kafka. My topic is apparently called transcript topic. And I am decoding JSON messages. Then I've got the good old Bootstrap server list, as I normally would when connecting to a Kafka cluster. So really, at the table level, this table is saying, that is my Kafka cluster, that cluster over there, and that's the topic that I want to consume from. That's the format of the messages that I expect to find in there. And of course, that format is going to need to correspond to the schema of the table that we've created. As I said, I didn't show you the schema file, so we need to make sure that the fields in the JSON messages in this topic, those field names actually match up to the column names in our table. That's what it means to connect a table to a topic when we're building a real-time table. So in terms of the components of our cluster, here's our cluster diagram. I'm not showing any minions here because minions are not directly involved in any way in real-time ingestion, but I've got Kafka off to the side. I've got some brokers. I got some servers. I got my controller. I got my zookeeper. What's going to happen? Well, when I create that table, I run the add table command. By doing that, creating a real-time table, I've said where my Kafka cluster is, what the address of the Bootstrap servers is, any credentials I need, the topic name, all that stuff I need to spin up a consumer. And so the controller is the one that I tell that to when I create the table. I'm telling the controller to create the table. And so it now is going to say, okay, hey, server 1, you've got the duty. I want you to connect to this Kafka cluster. And so it will. That server now spins up a Kafka consumer, creates a consuming segment, and starts consuming. Of course, we can tell it, do you want to consume from latest or from earliest, all that normal Kafka stuff, but it starts consuming, messages are coming in, consuming segments filling up, just like we said, and it's writing segment files. Now, behind the scenes, when that server is writing those segment files, it is asking the controller where they should go. It's doing the normal uploading of a segment into the cluster, and that does loop through the controller. But just to keep things simple here, we're showing those segments flushing to the same server. Now, they will be, over time, distributed to other servers. In fact, it's even possible, under some circumstances, once we do a flush, that another server might be the one to spin up the consumer and be the new place where the consuming segment is and where that Kafka consumer lives. That can move around the cluster while a real-time table is alive and being consumed. But the basic idea is we consume messages, put them in the consuming segment fills up, we create static segments on disk. And that, at a very top level, is how streaming or real-time ingestion works in Pinot.